Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With 200 gigabit private networking, node balancers, a 40 gigabit public network, fast object storage, and a brand new managed Kubernetes platform, all controlled by a convenient API, you've got everything you need to scale up. And for your tasks that need fast computation, such as training machine learning models or running your CI and CD pipelines, they've got dedicated CPU and GPU instances. Go to pythonpodcast.com/Linode, that's Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. You listen to this show because you love Python and want to keep your skills up to date. Machine learning is finding its way into every aspect of software engineering. Springboard has partnered with us to help you take the next step in your career by offering a scholarship to their Machine Learning Engineering Career Track program. In this online, project-based course, every student is paired with a machine learning expert who provides unlimited one-to-one mentorship support throughout the program via video conferences. You'll build up your portfolio of machine learning projects and gain hands-on experience in writing machine learning algorithms, deploying models into production, and managing the lifecycle of a deep learning prototype. Springboard offers a job guarantee, meaning that you don't have to pay for the program until you get a job in the space. Podcast.init is exclusively offering listeners 20 scholarships of $500 to eligible applicants. It only takes 10 minutes and there's no obligation. Go to pythonpodcast.com/springboard and apply today. Make sure to use the code AISpringboard when you enroll. Your host as usual is Tobias Macey, and today I'm interviewing Samuel Colvin about Pydantic, a library for enforcing type hints at runtime. So Samuel, can you start by introducing yourself?
Hi, I'm Samuel. I am a software developer. I split my time usually between a SaaS company, TutorCruncher, I've been working on for many years, and on unhelpful, which is a very exciting health tech company. We do blood and genetic testing to give people actionable health data, and then I also spend too much of my time doing open source.
And do you remember how you first got introduced to Python?
I do. I got offered an internship when I was at university by a company that used Python quite a lot. I actually didn't do the internship, but I played with Python and got hooked. I've done quite a lot of developing in other languages, in MATLAB and C# and Julia and Rust, and obviously, like everyone, JavaScript, but I've always come back to Python.
And so a few years ago, you started the Pydantic project, and I'm wondering if you can give a bit of a description about what that project is and what it is that motivated you to create it in the first place.
Yeah, I can remember the problem I was trying to solve. I was trying to parse a dictionary of HTTP request headers into a kind of class, a bit like a data class with some properties that had type annotations. And I was really frustrated that all of the validation libraries that I could find didn't respect or care about type annotations. In fact, they directly conflicted with them. So I guess I started digging, found you can get access to the annotations, and went from there. And a few days later, I released version 0.0.1, and some people used it. It got quite popular on Hacker News right then, and the rest is history.
And so in terms of the main use cases that benefit from Pydantic, you mentioned being able to parse a dictionary of headers into a class object, but what are some of the other ways that it's being used?
So the fun and the challenging bit of Pydantic is that it's used in quite a lot of different situations. So it's used for settings management. You can think of it a bit like the settings.py file in Django, or in any server project where you would have a settings of DSN for connecting to databases and what port and 1,000 other different settings. But it's also used for kind of API form data validation. And then I think people use it at library boundaries. So to confirm when people are using an external library that they are passing that library the correct arguments. And then it's also used by data scientists in a data processing pipeline kind of scenario. So the range of different ways in which it's used has been really interesting, but it's also been, in certain situations, a bit confusing, I think, for developers who assume that everyone else is doing with it what they're doing. About a year ago, Sebastian Ramirez, who I think you interviewed a couple of weeks ago, started Fast API, which uses Pydantic, and that's where the library really took off in terms of its popularity. But what's been really interesting is since then, its usage has really exploded, not just with Fast API. So Pydantic now has just a bit over 1 million downloads a month, so quite a lot more than Fast API and the other libraries that use it. So it's obviously being used, I suspect, somewhere by big corporations who are running CI thousands of times a day, which is why it's being downloaded so much.
And in terms of the use cases that you're seeing for it, the web API is one sort of obvious avenue for it. And then you also mentioned it being used in the data science and data engineering contexts. Are there any ways that it's being employed that you found to be particularly surprising, or any types of feature requests that you're getting for given contexts that you have either been sort of surprised and delighted by, or had to actively turn down in terms of trying to avoid feature creep?
Yeah, the feature creep issue is definitely challenging because of the demand for people wanting it to use it in lots of different situations. There's a issue around strictness in how you validate or parse data, which I think we'll come on to in a bit, which is definitely problematic because different people have very strong and different ideas about how it should work in those regards. I guess when I first started using it, I was always thinking about kind of dumb data, so JSON type inputs, strings, mostly strings, but also obviously floats and ints. But obviously a lot of the time it's used in contexts where the inputs can be quite complex Python objects. And so a lot of its usage has expanded to do validation of those complex objects. That it definitely wasn't how it first started.
And there are a number of other libraries that exist in the Python ecosystem for being able to do various things like settings management, which Pydantic is focusing on, and that try to enforce different sorts of best practices. And then there are also another suite of libraries for being able to do things like define data schemas or define validation logic for input data structures, such as Marshmallow and Cerberus. I'm wondering if you can give a bit of an idea of the comparison of how Pydantic fits in both of those different ecosystems and some of the reasons that people might want to choose Pydantic over the other available options.
So looking at the settings case, first of all, I'm a big fan of the 12-factor app approach to building applications. And so a Pydantic base settings class will automatically read and infer environment variables or environment variables defined in a .m file. So you can think, if you've ever used Django, you'll have a settings file, but a great number of your default settings will have os.getEnv around them to allow you to overwrite that default. That's automatic in Pydantic, but of course, because it also coerces types, it would automatically coerce a string to say an int or a path or whatever else you might want it to be. The main difference, of course, is that it uses type hints to define what your types should be. So you don't have to set that out twice or conflict with type hints. I also think that tests need to be a first-class citizen when you think about settings. So a settings class can also take arguments when you initialize it, which will overwrite the defaults, but also environment variables, making it really easy to use in a testing situation. And then lastly, Pydantic isn't tied to any particular framework or ecosystem. So it can be used by tools like FastAPI, but it's not tied to them, so it can be used in any library you like. In terms of comparing it to tools like Marshmallow and Cerberus, as I say, the first thing you'll notice is that type hints are used. The second thing will be speed. Pydantic is about 2.5 times faster than Marshmallow, and from our benchmarks, 26 times faster than Cerberus. I think Cerberus must have some problem there, because I've asked question on Stack Overflow and I think on their repo about why it's so slow, and I've never got an answer. So it seems that Cerberus is very slow. But Pydantic is faster than all of the other libraries that we've benchmarked, or on a par with the fastest ones. It's compiled with Python, and there are binaries available on Linux for Linux, Mac, and Windows from PyPI, which is one of the reasons it's so fast. But even without that, it's among the fastest of the validation libraries. As you will learn when you start using Pydantic, we lean towards coercion over strictness, unlike other libraries, which is confusing in some scenarios, but mostly it's useful. If you think about parsing like get arguments, the values there will always be strings. If you had some value, let's say age, that you wanted to be an int or a time delta or a date time, you need to have that coercion. There's no way that you could do strict validation that the input value must be an int, say, when the inputs have to be strings. And lastly, I'd say I hope that we managed to be friendly and helpful on GitHub. Unlike lots of projects, Pydantic allows people to ask questions on GitHub, and I try to always be as helpful as I can, which, to put it mildly, isn't true of all projects.
And because of the fact that you are addressing these two different use cases of being able to be used for settings validation as well as being able to handle validation of input and output data or data as it traverses an application, what are some of the tensions or challenges that you face, whether it's technical or conceptual or just for in terms of requests from the community that you're facing in terms of being able to build a library that addresses these different use cases?
So I said earlier that Pydantic leans towards coercion over strictness. So if you pass it a string of a number, so a string of the characters 1, 2, 3, into a field which is an integer, then it will convert that string to an integer. That occasionally confuses and frustrates people, and they say, oh, it should be strict, and say that it refused that string to be the input to an int. If you then say, well, what would happen if I passed you a string to a path field, for example? They would say, oh, well, it should definitely do coercion then. And the conversation goes on, and what you realize is that the person you're speaking to is thinking in the JSON world where you have the 7 types of data in JSON, and they assume that there should be no coercion between them, but there should be coercion from those JSON types to higher types like, I don't know, UUIDs or paths. So one of the problems I've seen, and it's quite understandable, is people assuming that other people's usage is similar to theirs. And therefore, they might assume everyone's using it for an API where everything's JSON, where actually it's being used in lots of other contexts. Or they might assume that the data being passed in is lots of different Python objects, and that JSON is not relevant. That's been a problem both technically in how strict Pydantic should be, but also conceptually to explain to people that it's used for lots of different things, which is great, but it can also lead to slight confusion.
In terms of the actual usage of Pydantic, from looking at the documentation, it's largely based around building up these class objects that act as containers for the different data fields. And in a lot of ways, it's very similar to the data classes that were added in Python 3.7. So I'm wondering what you see as being the trade-offs of using the built-in data classes versus Pydantic, and what the sort of challenges were that you faced in when data classes were added as a first class concern, given that it seems that you started the project before they were part of the mainline Python.
Yeah, Pydantic was released first for Python. I think it was 3.6, which didn't have data classes, and we had to support them later. So Pydantic has its own version of data classes, which are really just validation on top of standard data classes. So the data class you get when you initialize a data class that uses the Pydantic's decorator effectively will be a completely vanilla data class, just that validation will have gone on. More generally, the number one trade-off, of course, is that data classes don't do any data validation. So it might say foo needs to be an int, but if you pass it a string or a nested dictionary of UUIDs, data classes isn't going to care and isn't going to do anything. And so you're relying on MyPy or static type analysis to check that that's actually true, where obviously Pydantic does the runtime type checking. The second big difference is that data classes use the pattern, or arguably anti-pattern, of generating a bunch of Python code and then calling eval on that to create the data class, which is quite slow and prevents you from doing things like compiling with Python, which Pydantic data classes don't do. So Pydantic data classes don't do any of that eval stuff, and so they can work with Python. The only case implicitly where that happens is when we're using our own variant of standard library data classes, where of course we have to use the standard initialization of a data class once we've done the validation. And then the third big difference is that, of course, Pydantic has lots of other tools on top of it, whether that be parsing JSON, validators, serialization of things like JSON, nested data structures. All that stuff is available in Pydantic that's not going to be available in the standard library data classes, which are kind of a building block. So simpler, and they're great, and I use them quite a lot, but they're not right in every scenario.
So because Pydantic is a library, and also because it's doing this runtime type checking as opposed to just the ahead of time validation that you might get from a linter or something like MyPy, what are some of the points of overhead or the potential complications that get added by using Pydantic in place of the built-in capabilities or doing this ahead of time checking?
Well, it's going to be a lot slower, of course, to call a function where you go through the whole of data validation before you call the function. That's unavoidable. There are cases where it's better to use the kind of duck typing and catch the error approach rather than doing the validation first. But of course, there are cases where you need validation. Compared to handwritten validation, because of the compiling, Pydantic is generally on a par, maybe slightly faster or slightly slower than handwritten validators. So it is, of course, slower than not doing validation. But if you're going to do validation, Pydantic is pushing towards the fastest you can do it in Python, I think.
And as far as the conversation that we started of strict validation versus type coercion, I know that you added some explicit points in the documentation to be able to call that out to avoid confusion because of some conversations that came up earlier in the life cycle of the project. And I'm wondering if you can talk a bit more about some of the nuances of that strictness versus coercion and some of the ways that it manifests and some of the limitations that you see in terms of the use cases by explicitly not supporting that strict validation in favor of being able to do the coercion.
Yeah, I mean, Pydantic started off trying to be fast and trying to be simple. And so I took the approach that if I want something to be an integer, then the simplest thing to do is to call the int built in on that value. And if it succeeds, then you know you've got an integer. And if it fails, then you take that error and you use that as a basis for the exception you're going to throw. And in most cases, we still do that. And that does mean that, for example, if you pass it a string, that will be passed to an int. Or if you pass something to a list, it'll just call the list built in and give you back a list. There are cases where that makes no sense. So, for example, virtually everything can be cast to a string because it has the string method on it. And so it wouldn't make sense just to call string on everything and say, if it can be passed to a string, then it is a string. It wouldn't make any sense to have, if you pass a list of integers to a field you expect to be a string, for you just to get back the string representation of that list. But there are some other weird ones that people came up with early on, pointed out were mistakes that we fixed. So, for example, before, because you were just calling list on something to see if it's a list, and then calling, for example, int on something to see if it's an int. If you passed a string of 1, 2, 3 to something that tried to be a list of ints, you got back the list 1, 2, 3, which was very confusing. So there are cases where we've gradually moved to be slightly stricter in the right places. I think that's the right approach to take. There's still, to some degree, an open. Well, there is an open issue literally, but there's also an open issue in my head about whether we should have a completely strict mode. But from what I've seen, when you explain to someone what a completely strict mode means, things like path has to be an instance of path, not a string, that generally isn't what people want. So I think we will avoid going completely strict and instead move towards slowly making things stricter in the right ways, but only have one mode. And if you really want to be stricter, you can use validators to do that yourself. In terms of cases where that means it doesn't work, if you had a kind of testing situation where you wanted to test the output of a webhook or of an API, Pydantic wouldn't be the right tool because it will lean towards doing coercion instead of just checking. There are some cases where you could lose data. For example, if you had a float of 3.1415, you pass that to an int, you'll silently lose data because it would convert that to the int 3. But most of the problems, I think, really come from developer confusion, that they assume it would be strict. And that's where they kind of end up getting confused and getting into trouble. And then I get a slightly irate issue saying, why the hell does it work this way?
And for those cases where there is the potential for data loss, I know that in some ways it's potentially impossible to be able to determine ahead of time if there is any sort of lossy conversion that's going to happen. But have you explored the possibility of adding in some types of warning or being able to capture hooks of this is going to lose data and then being able to raise errors during the development cycle or anything along those lines for giving people that option of lossy versus lossless conversions?
Well, we thought about the strict mode would be I think would be the route there. So you would enable the strict version of data class during testing, and then you would know that in testing it was working. That's just a lot more work and not something that I think people actually want in the end. If you look at libraries like, I don't want to pick on Cerberus, but I know that you have to explicitly set up any coercion that you want, which is in some ways more explicit, and explicit is better than implicit, but it does also mean that every single place you want to use some higher order object that will require some coercion, you need to explicitly set that, whereas Pydantic tries really hard to just work out of the box in the most likely scenario. I mean, I built it for me, for projects I needed, and so I built it the way I wanted, and to a degree, unless people pay me, they can kind of have it the way I want it, to be a bit blunt about it.
And that brings up an interesting point, too, about the API design of the library and how you approach the overall philosophy of the structure of the project and the interfaces that you expose to users. And I'm wondering what your prior experience experience has been in terms of building out projects that are more widely used, and what your thoughts are in terms of how to design that API in a way that is easy to adopt as well as being appropriately expressive for the problem space that you're working in.
I think it's a difficult and nuanced problem. I think that humility is quite a useful attribute of a developer, and probably an under-considered one. Trying to remember what it was like when you first started developing and remembering how little you understood is really valuable when you're building open source code that will be used a lot by junior developers. And I mean, Sebastian Ramirez, who built Fast API, who's helped me a lot on Pydantic, is the master at that. He seems great at creating open source projects and getting them to grow, and doing it in a way which arguably isn't even always the technically perfect way, but which allows the most people to use his code and to get something done. Then there are like more practical things you can do. I know Sebastian was talking on your podcast previously about things like setting every keyword argument explicitly in the public-facing API, so that with IDE type hints, you can kind of get there without having to use the documentation. Lots of projects don't do that, and it's really frustrating. So I definitely try and get things like that right and make it easy to use. I suppose my overall approach is, as long as it's fast and it's easy to get started with, I'm happy to skip some edge cases and allow people to fix them themselves or use another tool. I guess it's better to be right for the majority of people and usable than do everything.
And in terms of how Pydantic itself is implemented, can you talk through the overall design of the project and some of the ways that it has evolved since you first began working on it?
So the biggest change is that we got to version 1 late last year. There were a few understandable complaints from big projects using Pydantic that it was a moving target. Pre-version 0.1, I was quite keen on breaking things to make it better. And that understandably frustrated people who had it as one of many dependencies. So we got to version 1, and I've tried really hard to avoid any backwards incompatible changes since then. The main other change in Pydantic over the years has been the fact that there are now 4 main interfaces to Pydantic. So there's the base model approach, which is the primary one. Then there's Pydantic data classes, which I talked about earlier. Then you have parse as object, which allows you to parse or validate any object you like. So you give it the type and you give it the raw data, and it will either succeed or fail. And then most recently in version 1.5, we released validate arguments, which is a function decorator that allows you to validate the arguments of any function. And then Sebastian added back, when he was first working on Fast API, schema generation using JSON schema, which was another big step forward for Pydantic. In terms of other changes, David Montague worked a lot on getting Pydantic to compile to Python, which has made a big difference to performance. That was one of the big changes we made last year.
And for the actual internal architecture of the project, I'm wondering how the actual class definitions are structured to be able to do things like gain access to the type attributes of the arguments to the class or of the fields within the class, and also in terms of the typing capabilities in Python itself. I'm wondering what you have found to be some of the well-considered aspects of it and any challenges that you face in terms of shortcomings of the typing system, because I know that whenever this conversation comes up, people will invariably look to things like Haskell for some of the more complex and elegant ways to handle complex types. But I'm wondering what your just overall thoughts are on typing in Python and the ways that you approach leveraging it within the project.
So the first bit of that question is super easy. In the meta class, it's really easy to get access to the attributes object, to annotations object on a class, and then use that as a basis for your validation. The tough bit is introspecting the types to work out what they are, and then developing code to suitably parse or validate data to check whether or not it's compliant with that. That's been the tough bit. I think that somewhere, although I was looking for it before this and couldn't find it, Guido has said that he explicitly doesn't think that type annotations are designed for runtime type checking. I think originally they said they're here, do whatever you like with them. And then later on, it was clarified that they weren't for runtime type checking. And that kind of shows when you try and start introspecting types. They're hellishly complicated to get access to what they are. It's one of the things that was a lot of the work early on in Pydantic. And still to this day, one of the frustrations is that you have, even if you think about a sequence of different integers, let's say you have collection, sequence, list, set, frozen set, iterable. There are many different versions of what you might generically call an array of integers. So that's been problematic again, and goes on being a problem. Not all of that is completely solved in Pydantic, but most of the time it just works still.
So for a developer who's interested in getting started with using Pydantic or integrating it into an existing project, what is the overall workflow of being able to add in those type definitions and some of the different capabilities that are exposed by bringing Pydantic into that project?
So getting started with Pydantic should be as simple as pip install Pydantic. That will give you a compiled binary on whatever operating system you're using. Then have a look through the docs and get started. I think it's almost in some ways too easy to get started because everyone already has an idea about how type hints work. That's probably one of the reasons that people find the pitfalls, because they haven't gone through the docs quite understandably like the rest of us. They just start going and end up running into problems. Those type hints are awesome because they then work with your IDE, with MyPy, with your own intuition, with any other IDE that you're with PyCharm or whatever IDE you're using. In particular, PyCharm has a plugin specifically for Pydantic built by the community, which is awesome, which makes usage of PyCharm with Pydantic even easier and even better. But yeah, the use of type hints avoids you having to learn another schema microlanguage for defining your models. You can just use standard Python and off you go.
And what are some of the edge cases that developers often run into, aside from the confusion about the strictness versus coercion of the typing information?
One of the useful divisions, I think, is that when you're defining your model, it can't look at the rest of the world. So let's say that you're creating a user with an email address and you need that email address to be unique. You can't do the check that the email address is unique within a validator in general, because that validator can't be asynchronous, and even if you're using asynchronous database lookup, it's generally bad practice to put that inside the validator. So using Pydantic gives you a very good division between checking the data is consistent and then checking that the data works with the rest of the world. But that's something that quite often leads to confusion, and there's a bit of tooling around how to raise Pydantic validation errors after you've done the initial validation, which I'm going to work on in future. There are some differences with data classes, even if you use the Pydantic data classes, mostly around implicit constraints of data classes. You can't have extra arguments to them, which occasionally people have problems with. And then there's a kind of complex question about whether or not to pass around Pydantic models or dictionaries created from Pydantic models or data classes you create, or how you then pass your data along. If it's simply as simple as accessing an attribute of a model and saving that to a database, that's fine. But obviously people have complex processing workflows and people have lots of different solutions for that. Pydantic works well with pickles, so you can just pickle your models, but even that occasionally leads to problems.
And for the capability of being able to access the different attributes and pass along the data, what are some of the sort of best practices that you have found to be useful, of whether you pass the exact model or just a representation of the data set and then do the coercion back and forth throughout?
I don't think there's a single good answer. I do occasionally end up with data classes that shadow models, which can allow, or at least shadow parts of models that I need in a particular context. Sometimes it is as simple as calling .dict on a model and getting back that dictionary and using that. But in general, I think that the best practice would be to continue passing the model around and using that model directly rather than converting it to a dictionary too early.
And another element of using Pydantic within these applications, particularly using the model terminology, people might get confused for those who are used to working with ORMs in different web frameworks such as Django. And I'm wondering what the options are for being able to integrate Pydantic with some of the other elements of the ecosystem, starting with things like ORMs of using it within Django, or with things like SQL Alchemy for doing the validation of the data as it's flowing into the application and then being able to easily convert it into a database object.
Yeah, I'm going to put Django to one side because I think the best and the worst of Django is that its battery is included. And if you're going to use Django, you're probably best using vanilla Django and Django RESTful framework and leaving Pydantic out of it. I'm sure that there are some cases where people do build stuff with Django but use Pydantic, but I definitely haven't. SQL Alchemy and other ORMs are a more nuanced question. Pydantic has a from ORM mode, which basically allows it to inspect the attributes of an ORM class and build a Pydantic model from there. I personally am not particularly pro ORMs. I would much rather write my queries in raw SQL or whatever than have this ORM step in between. So I haven't done that much recently with ORMs and Pydantic, and I would say ORMs are quite often a mistake full stop, so I don't put that much effort into using them myself, but I know many people do, and you do find yourself having to define your data twice in the form of a Pydantic model and a SQL alchemy model, but I think that's just unavoidable. At least in most cases, there are no doubt exceptions where you could auto-generate one or the other, but I would say unless you had thousands of different tables and therefore models, it wouldn't be worth it.
And talking about it in the context of databases also brings up the interesting question of the ability to define Pydantic classes that relate specifically to other classes so that you can do things like joining across different data objects or being able to specify relations of those different objects as it flows throughout your application. And I'm wondering what you have found in terms of some of the advanced usage capabilities of Pydantic that are not necessarily obvious at first blush.
One of the things I've been amazed by is how advanced many people's usage of Pydantic has been in regards which I definitely haven't done that. Pydantic doesn't have, and it's an open issue, a way of avoiding recursive links between models. So if you have, I can't think of an example right now, but you have a user linked to a pet, and then you have the pet linked back to the user, that can lead to recursive problems in Pydantic. It's an open issue. I'd love someone to come along and help with that. But in short, I haven't solved that because I suspect that models like that are an anti-pattern in the first place, and so they just shouldn't exist. I would much prefer myself to keep my models individual and not connected and have an integer field if there's a foreign key, for example, rather than having some implicit link to another model that automatically does a query that I can't see, because I think that complexity gets you into hot water when it's not really actually saving you enough time. In terms of other advanced usages or advanced features of Pydantic, the generic models built by David Montague are scarily powerful. If you think about generics in the context of Python typing, generic models are like that, but with validation on top. So you can define the model that has some generic type or types associated with it, and Pydantic will then go and do the validation based on dynamic types within the definition of the model. Another of the powerful features of Pydantic is custom types with custom validation and custom schemas, which I don't think people are aware of enough and don't get used enough. Probably the documentation could use some work there. One of the things that I often find suggesting as solutions to people who ask questions is custom-based models with custom config and even modified methods like the dict or JSON on a model, which gets around lots of people's requests for more features. And then the validation error system in Pydantic is quite complex. It allows things like custom translations and customized messages on errors, which are often, again, probably aren't documented well enough because people don't seem to be aware of that and the power of what that can do.
And another interesting capability that you touched on briefly earlier is the way to be able to generate things like a JSON schema from a Pydantic model. And I'm wondering if there is the capability of being able to do something like that in the reverse, where you have a schema definition and then being able to generate the corresponding model object for being able to validate other instances of that schema.
There are some third-party projects. I think there are at least two out there that generate either Python code or Python models. The problem with that is that things like MyPy and static typing and your own intuition aren't going to work because the model isn't defined in code somewhere. So in general, I would say that the Python code should be your single source of truth about the definition of what your data should look like, and then you should generate the schema from there. But yeah, there are tools that can generate Python code to represent a schema, and I'm sure there are contexts in which they're useful. I haven't used them myself.
And I'm wondering, too, if you have explored the space of being able to generate other types of schema objects beyond just JSON schema. So, for instance, in the data engineering context, being able to use a Pydantic model to be able to create instances of Avro objects or Parquet rows, things like that.
I haven't myself. I haven't worked on that. I would have said that the best approach would be to work from the current JSON schema dict and go about generating them from there, but I haven't had any experience myself.
And then as far as being able to integrate Pydantic with other frameworks, because of the fact that it is largely just vanilla Python, it seems like it's fairly straightforward for things like using it in the settings module of a Django project. But what have you found to be some of the useful tips in terms of the overall process of integrating with things like maybe the Dagster project for ETL workflows, or maybe Pyramid for being able to, or Flask for integrating it with other web frameworks or frameworks of other types that people might be trying to use the data validation capabilities within?
I've used it quite a lot with libraries like Starlet. Obviously, it's a cornerstone of Fast API. I know people use it quite a lot for settings management in Flask. I think there are some libraries around that. I haven't used Flask for a few years, so I haven't been working with that. It's become more and more a cornerstone of the data pipelines used in machine learning projects. It's kind of been amazing to see. It was an application I had never thought of before, but now you see all of these quite popular machine learning packages like Deep Pavlov and Transformers from Hugging Face using Pydantic for both settings management and for parsing the data before doing the machine learning, which has been really interesting. I haven't had much experience with them myself, but what's the kind of amazing thing about building Pydantic has been seeing other people pick it up and run with it and do stuff I had never thought of.
And what are some of the other interesting or innovative or unexpected ways that you have seen Pydantic used that you have been particularly surprised or impressed by?
Probably the most surprising thing for me has been big companies you would have heard of like Microsoft, IBM, AWS, NSA, Uber, Salesforce using Pydantic, which is never something I would have expected when I first hacked something together and released something on PyPI. In terms of particular projects, Facebook have their Fast MRI project for making MRI scanning faster, and their reagent machine learning library that used Pydantic. Microsoft used Pydantic through Fast API for core Windows and Office services, which is amazing. There's a Mexican neobank called Suenca, I hope I pronounced that right, who use Pydantic for their interbank transfer validation. The Molecular Science Software Institute use Pydantic a lot. As far as I know, they're using it for their COVID response, and lots of other projects in academia and in industry. Each of those projects is cool, but the most gratifying thing for me has been seeing the sheer number and diversity of different projects that have used it in ways I wouldn't have thought of.
And particularly for some of the scientific contexts, have you found people using Pydantic alongside things like Pint for being able to handle unit conversions and being able to incorporate that validation or transform logic within the Pydantic models?
One of the frustrations I find of writing open source code is that you can see the open source tip of the usage iceberg, but you can't see the closed source usage. And so it frustrates me. It's tantalizing to be able to see some of it and guess at what other people are doing with it, but not to be able to go in and actually understand what people are doing with it. So the short answer is I just don't know, because some of those projects are obviously open. And I'm sure if I spent some weeks digging away, I would find out what people are doing with it. I'm sure that would be very useful for me in terms of how I develop it further, but I haven't done that. But obviously a lot of the usage is closed source. And so you just don't know. But I mean, it's interesting because you get occasional intuition about what people are doing I had a credit checking agency who pointed out a bug the other day in a regex, and it never occurred to me that a company like that would be using it. So you occasionally get a hint at what's underneath the sea level of that iceberg, but mostly I don't know.
And in terms of your own experience of building and growing the Pydantic project, what are some of the most interesting or challenging or unexpected lessons that you've learned in that process?
It's been really fun working with some big companies. I would do that again, either commercially or just for free, out of curiosity to see how large organizations use it. There's a strange paradox when you start writing open source that on day one, you desperately hope some other people will install it and use it, and careful what you wish for, because 3 years later, I now spend 1 hour to 2 hours a day working on Pydantic, mostly just answering issues, which definitely wasn't what I planned to do, but has been really interesting. There's I talked earlier about humility and remembering what it was like not to know how to do things, answering a lot of quote dumb unquote questions from people who are relatively new to Python has been a good experience in reminding me how much I know in a sense, and how lucky I am to be able to write write code like I can. And so I do my best to give back and not to get frustrated by people asking questions that I think they could have worked out with a few minutes on Google.
Some of the other challenging aspects of open source maintainership are also things like knowing when to say no to particular feature requests, but also the quote unquote bus factor of the project and figuring out what is the succession path for maintainership if you decide to step away from the project or you're no longer actively using it and you start to want to spend your time on other things. And I'm wondering what your thoughts are on your own personal approach to that, or any other thoughts that you have in this sort of discussion of maintaining open source projects.
Yeah, I think it's really hard. And I wouldn't deny that the bus factor wasn't quite big with Pydantic right now that I'm the majority of the work. It is really gratifying to see other people, particularly Sebastian Ramirez and David Montague, but lots of other people as well, contributing to it, taking time to answer questions. But I think it's a outstanding big problem. I think that we do a lot of patting ourselves on the back and saying how great open source is. But I was reading an essay by John Mark, which I'll leave a link to, called perhaps slightly hyperbolically "Open Source Has Failed." I wouldn't say I would go quite that far, but I definitely don't think it's quite as rosy as it should be. And I definitely see the problem that all these big and very profitable companies use a library like Pydantic, and of course many more, but don't contribute financially. And that then leads to a bus factor with projects like this, that and even more so with Fast API. If you look, I think Sebastian is amazing and he's done lots, and it's got incredibly popular very quickly. But I don't think that any of the organizations that use that have a succession planning and have thought about what would happen if those libraries stop being maintained. I mean, I think the good thing is, at least with Pydantic, it's relatively stable. I have lots of interesting things I want to do on V2 that I will one day get around to working on. But without that, it's not like it's going to suddenly crash or fall to the ground if it doesn't have any work on it for a few weeks or a few months.
And in terms of selecting the sort of libraries to use within an application, if people are looking at Pydantic, what are the cases where it's the wrong choice and they might be better suited using maybe built-in data classes or something like Marshmallow or some other settings management library?
I'd say the first case is that it's not a substitute for strictly typed compiled languages like C++ or Rust or Go. And you see occasionally questions where I wonder whether the real answer here is you shouldn't be using Python. It's not. It helps get around some of those problems, but it's not going to be a substitute for them. I also think that it's often the old-fashioned Python approach of kind of duck typing and catch the error, easier to ask forgiveness than permission, just try it, works well. And if you end up validating every single input in Python, it gets really, really slow. So often, if you are reasonably sure about the inputs and if there's no particular security concern of just calling it and seeing what happens, then that's often a better approach. It's also obviously wrong, as I said earlier, in the validation context for, say, a testing case where you want to confirm that a webhook or an API is giving you the right data. That's not the right tool for Pydantic because it leans and always will towards coercion over strictness. But if you are determined to write Python and if you want to do validation, I think Pydantic is probably the best tool in most scenarios. That's obviously my biased opinion.
And as you continue to work on and maintain the project, what are some of the things that you have planned for the future of it, and maybe some of the ways that you're planning on using it in your own work?
Yeah, I'm heading towards V2 now, and I've got quite a lot of big features that I want to work on in V2. Some stuff I want to break to get right. So I think validators, currently you can think of them like a list of functions, and each function is called in turn, and the output from one is given as the argument to the next, unless an error occurs, of course. That's slightly slow and somewhat confusing. I would much prefer validators to work a bit like middleware. So it's a function stack, and each function calls the next function along, but from the outside, that just looks like one function, which should be faster in the case that you are doing some common piece of validation where it is just one function, but also much more powerful because you could do your checks before or after calling the next function without having to mess with the order of those validators. I also think one of the things Marshmallow does well is it makes serialization a kind of first-class concern. So it's not just about the parsing stage, but it's also about the output stage. And Pydantic has quite a few things I want to work on in that regard. So input and output aliases, computed fields. So fields on a model that don't come explicitly from an input, but instead are computed either eagerly or lazily based on other fields. And there's a whole bunch of other stuff. Have a look on the V2 milestone on GitHub, and I'd love some feedback.
And are there any other aspects of your work on Pydantic or the overall field of data validation and type checking, things like that, or any ways that you're looking for help from the community that we didn't discuss that you'd like to cover before we close out the show?
Oh, I would say that I've got quite a lot of issues with a label called feedback, where I'd love people's feedback. Obviously, there's a risk of just bike shedding, but getting people's input is really useful before you release a feature rather than them being furious once you've done it. So I don't need people to write code or submit issues, but just a bit of feedback, a +1 here or there, makes it much easier to work out what people are looking for. Other than that, nothing in particular.
Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And so with that, I'll move us into the picks. And this week, I'm going to choose something that I had forgotten about for a while and remembered during a conversation with my family the other day of the devil sticks, also known as juggling sticks or flower sticks, as some way to pass the time and have something to keep your idle hands busy. So if you're looking for something to do or play with, I'll definitely recommend checking that out. And so with that, I'll pass it to you, Samuel. Do you have any picks this week?
I do. In terms of books, I would thoroughly recommend Flash Boys by Michael Lewis. I know it's not that recent, but it's an awesome book. In fact, everything by Michael Lewis. I'm a massive fanboy of him. Then in a more computing specific context, there's Algorithms to Live by Brian Christian and Tom Griffiths, which is an awesome book. It's much better than its title suggests. In terms of TV, I really enjoyed Sex Education on Netflix. If you're bored at home at the moment, I would thoroughly recommend it. It's extremely funny. And then in terms of tech, I found recently a website called ngrok.com, which creates a tunnel from a port on your local machine to the public internet, which is awesomely helpful when developing and you want to show something to someone, or if you want to have an HTTPS connection to a local port. That was a really nice to find, really useful tool.
All right. Well, thank you very much for taking the time today to join me and discuss the work that you've been doing with Pydantic. It's definitely a very interesting project and one that I'm planning to take use of in some of my work. So thank you for all of your time and effort on that, and I hope you enjoy the rest of your day.
Thank you very much. You too.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.